Um, the topic that I'm going to discuss is about equilibrium of rigid bodies. Okay. First, with the dimensions. When the force and the couple are both equal to zero, the external forces form a system equivalent to zero, and the rigid body is said to be in equilibrium. So, uh, if the force and the resultant force and resultant couple are both equal to zero, then the rigid body is said to be in equilibrium. The necessary and sufficient conditions for the equilibrium of a rigid body, therefore, can be obtained by setting R, resultant force, and M sub O, R, resultant moment, equal to zero. So, sa R, dimension of force, no? Resultant is the sum of all forces and equal to zero. And then moment, if you use vectors, that's R cross F. Summation of R cross F equal to zero. General, 2D or 3D. Now, resolving each force and each moment into its rectangular components, we can express the necessary and sufficient conditions for the equilibrium of a rigid body with the following 6 scalar equations. Kung i-resolve na to, ang force and moment into rectangular components, this is the result. So, kato summation of force equal to zero, ato to siyang i-break into components. So, summation of force sa x equal to zero, and so with y, and then if 3D, included ang summation of force along z. Same with moment. Summation of moment sa x equal to 0, y 0, and z 0. For 3D, no? For 3D. Okay. So, in solving a problem concerning the equilibrium of a rigid body, it is essential to consider all of the forces acting on the body. All forces, it is equally important to exclude any force which is not directly applied to the body. Be careful of that now. Basin ma-include nimo sa forces. Omitting a force or adding an extraneous one would destroy the conditions of equilibrium. Like, you add a force na dili connected sa body, or you forgot to include a certain force na included dapat, wrong na yun ang analysis nimo. So, steps to follow in drawing a free body diagram. Number 1, choose the free body to be used, because in some problems, there is more than one rigid body to be considered. So you have to choose which rigid body to be used. This body is then detached from the ground and is separated from all other bodies. Detached from the ground, for example, if there is a support, you remove the support. Okay? So i-detach nimo sa support ang rigid body. Separated from all other bodies. Number 2, external forces should be indicated on the free body diagram. We have discussed external forces sa particle na topic. So, all external forces should be indicated on the free body diagram, like tension sa cable na naka-attach sa body, reaction sa support, those other forces. Weight. These forces represent the actions exerted on the free body by the ground and by the bodies which have been detached. Okay, so anyway, free body diagram was already discussed sa previous na video. eh, sa equilibrium of a particle. The magnitudes and directions of the known external forces should be clearly marked on the free body diagram. Magnitude and direction. Number 4. Unknown external forces usually consist of the reactions to support, through which the ground and other bodies oppose a possible motion of the free body. Okay, unknown external forces. Number 5, the free body diagram should also include dimensions, since these may be needed in the computation of moments of forces. This is very important. You'll be able to determine all dimension, distances, angles, because they will be needed sa computation sa moment. Okay, so let us know the different supports and connections. First, for a two-dimensional structure. And we will know also the corresponding reactions of each support. If the equilibrium of a two-dimensional structure is considered, it is assumed that the structure being analyzed and the forces applied to it are contained in the same plane. Kaya two-dimensional naman. So, planar sa structure. Clearly, the reactions needed to maintain the structure in the same position will also be contained in this plane. So, X and Y only, or XZ or YZ. Okay. Depende sa problem. The reactions exerted on a two-dimensional structure may be divided into 3 groups corresponding to 3 types of supports and connections. 3 groups. Okay. The first one, reactions equivalent to a force with known line of action. Okay. Supports and connections causing reactions of this type include rollers, rockers, frictionless surfaces, short links, and cables, collars on frictionless rods, and frictionless pins in slots. Each of these supports and connections can prevent motion in one direction only. Okay. What are these connections? This one, roller. Muna roller, pag na-ligid, na-circle roller, na rocker, frictionless surface. So, analyzing this one, ang roller, free siya move sa horizontal, pero dili siya pwede mag-move sa vertical. Same ra po sa rocker or frictionless surface. Kaysa horizontal, almost slide man sa frictionless man. Sa Y, di pwede. So therefore, ang reaction niya is this one. You only have one reaction with known line of action. Okay. Known line of action is the reaction is perpendicular sa surface. It's not vertical. Perpendicular sa surface. It happens na ang surface is horizontal. Therefore, vertical sadya. Pero in general, this is perpendicular sa surface. So, pag inclined ang surface sa roller, ang reaction inclined sa perpendicular sa surface. Known siya. Upward siya. Why upward? Because like this one, if i-pull nini mo upward, dili siya ka-resist. Di ba? Dili siya ka-resist. So, dili pwede na ang reaction niya is downward. Kaya kung imo siya i-pull upward, free mo siya ma-pull man siya upward, di ba? No resistance. So it's impossible na ang force, ang reaction nimo is directed downward. Pero kung imo ni i-push downward, mo resist man yung surface, na reaction. this one. Okay. Na reaction siya. Same also with rocker and frictionless surface. I-pull na nimo upward, free na siya, no reaction. Pero kung imo na i-push downward, apply kag force downward, mo resist na siya. So there is a vertical reaction. Number of unknowns, 1. Okay. Another one, short cable and short link. So, of course, ang force ani isa lang. Along sa cable or along sa link. And tension siya. Because dili ni design sa compression. This one. Tension siya. Force with known line of action. Number of unknowns, 1 also. And then this one, collar on frictionless rod and frictionless pin in slot. You only have one reaction. The reaction is this. Perpendicular sa axis of motion. So, kung asa mag-move ang collar o kining pin, perpendicular na dito force. And then away siya. Away, dili pwede na inward siya. Outward siya. Mo na yung reaction. 1 also. So for this group, you only have one reaction. Roller, rocker, frictionless surface, short cable, short link, collar on frictionless rod, and frictionless pin in slot. Always remember that now there is only one reaction, and the line of action is known also. Number 2. Reactions equivalent to a force of a known direction and magnitude. Supports and connections causing reactions of this type include frictionless pins in fitted holes, hinges, and rough surfaces. They can prevent translation of the free body in all directions, but they cannot prevent the body from rotating about the connection. Dili niya pwede, dili siya ka-resist o rotation. Pero mo resist siya o translation. Okay. This one, frictionless pin or hinge, rough surface. Like it, frictionless pin. If you must i-pull to the right or left, mo resist niya. Therefore, there is a reaction along the horizontal or along ani na surface. Okay. Pag i-pull siya upward, mo resist. Pag i-pull downward, mo resist also. So, nasa reaction sa vertical or simply perpendicular sa surface. Same also with drop surface. Okay. There's resistance on both the horizontal and the vertical. So, ang reaction niya, duha, two unknowns or this one. Pwede ka resultant, pero with angle, so you still have two unknowns. Resultant, magnitude, and direction or components. Depende lang. Now, for this one, assume na Assume na right and upward now. The moment na mag-negative ang answer, you just change the direction. Okay. So there are two unknowns, okay? Now, number 3, reactions equivalent to a force and a couple. These reactions are caused by fixed supports, which oppose any motion of the free body and thus constrain it completely. Oppose any motion, translation, and rotation. So, dili pwede mag-move along sa X, dili pwede mag-move along sa Y, dili sad siya pwede ma-rotate. Fix siya sa support. So, pag mga apply kag force horizontally, mo resist. Pag mga apply kag force vertical, mo resist. Pag i-rotate nimo, mo resist siya. Ana, fixed support. So, ay horizontal, vertical component, moment, or resultant to the direction, and then moment. You have 3 unknowns. So, these are the 3 groups. First group, second group, and the third group. The equation of equilibrium for a two-dimensional structure can be written in the more general form. Summation of force x equal to 0, summation of force along y equal to 0, and summation of moment at a certain point a equal to 0. Okay, planar man. So, isa lang ka moment. Okay? About the z-axis. Hindi pwede sa x o y. So, we have three conditions of equilibrium. Therefore, there must be only 3 unknowns probably. Where A is any point in the plane of the structure. The 3 equations obtained can be solved for no more than 3 unknowns. Dili pwede ang 3 unknowns. We already know that the unknown forces include reactions and that the number of unknowns corresponding to a given reaction depends upon the type of support or connection causing that reaction. Okay, let us solve some problems. 2 links, AB and DE, are connected by a bell crank as shown. Knowing that the tension in link AB is 720 newtons, determine the tension in link DE, this one, and the reaction at C. Okay. Let's draw the free body diagram. So therefore, i-detach na to ang support sa C, no? We'll choose BCD as our body, rigid body. So i-detach na to. So, wala na ang support sa C, no? And then identify all forces. Given siya, knowing that the tension in link AB is 720 newtons, this one. So, muna ang given, and ang ano na to, tension sa link DE, and the reaction at C. So, pin man eh. There are 2 reactions, horizontal and vertical. Again, assume na yan. The moment na mag-negative siya, you just change the direction. Now, from the free body diagram, if there are any inclined forces, you have to resolve it into horizontal and vertical components because we are going to apply summation of forces along x and y. So therefore, i-resolve mo siya into components along x and along y. So, and we need the angle, this one or this one, para we can get the components. We start with this alpha. Okay, natay 60 and then 80, so we can solve for alpha. Now, if this is alpha, kay alpha 90 minus alpha, so alpha. Kaya alpha na yan. So, that's all for alpha. Tangent alpha is 60 over 80. And we can solve for alpha. That's 36.87. So after this, we can now resolve the 720 Newton force into a component naman tayo alpha. Now, if you look at the diagram, the angle is referred from the vertical. Therefore, ang vertical, ang cosine. Ang horizontal, ang sine. Kaya adjacent man ang vertical. Opposite na dayon ang horizontal. So resolve the 720 Newton force into X and Y components. X component is 720 sine of alpha. That's 432. So 432 na. And then sa vertical, cosine. Cosine alpha and 576. So once mo apply ka sa condition, it is no longer 720 newtons but components na 432 and 576. So since all forces are either horizontal or vertical, we can now use the equilibrium conditions. So we write the following three equilibrium equations and solve for the reactions indicated. Summation of force along x equal to 0. You only have two forces now. To the right, positive. So we have this one, Cx minus 432. Therefore, Cx is directed to the right. Kaya nag-positive man siya. Therefore, correct ato ang assumption na right. So, right. Now, why summation of moment sa C and not summation of force sa Y? If you will sum up summation of force along Y, you still have two unknowns. If DE and CY. Therefore, you sum up moment first along about point C. So that's 0 nisa. And you can solve for if DE. Okay. Make sure that all dimensions, distances are ready para sa computation of moments. Like for this one, if DE, the perpendicular distance of FDE to C is 120. For this 4576, the perpendicular distance is EP. And for 432, the perpendicular distance is 60. Okay. This one. Counterclockwise, positive. So 576, that's positive counterclockwise man, times distance 80. 432 counterclockwise also. 432 times 60. And then FDE clockwise, FDE times 120. So you compute FDE is equal to 600 newtons. Downwards, tension. And then summation of force along Y. We have three forces, FDE, CY, and 576. Okay, puro downward, so negative. And CY is equal to 1176 newtons. Positive man, therefore upward. Tama mo itong yes yung upward. So, we have the components already for C, and we can now solve for the magnitude and direction of the reaction at C. Okay. Actually, these are correct, Cx and Cy, correct na. But if you want to solve for the resultant and the direction, magnitude and direction, okay. So you can plot Cx and Cy. Cx is directed to the right, 432, and then Cy upward. And then construct a rectangle. The diagonal is the magnitude RC and then angle from the horizontal. So to solve for the magnitude, use Pythagorean theorem. And then for theta, arctangent of Ry or Fy over Fx. Okay, 69.83. Therefore, the reaction at C is equal to 1,252.84 at an angle 69.83 from the positive x-axis in a counterclockwise direction. Okay. Another problem. For the frame unloading shown, determine the reactions at A and E when alpha is equal to 30 degrees. Okay. free body. Okay. Now, as I've explained a while ago, ang reaction sa roller is perpendicular sa surface. Perpendicular, ha? So it's not vertical. Perpendicular sa surface. So for A, Hinzman, so AX and AY. Sa E, perpendicular sa surface. So we have three unknowns. AX, AY, and then E. Okay? Oh, but again, make sure na all forces, inclined forces must be resolved into horizontal and vertical components. Tama mo na ang required sa pag-sum up of force, X and Y. So we have to resolve E, the reaction at A, into horizontal and vertical components. Now, alpha is given 30 degrees. Okay? 30. So, 16 eh, 30 eh. 60. So, pwede natin resolve. That's E cosine 60. Kay 60 is referred sa X man. While ang Y, EX, and then EY. Our EX is E cosine 60. EY is E sine 60. This one. Okay. And also this one. So, pag-apply, you can replace E by this one, EX and EY. Okay, this one. So, we can now apply the conditions of equilibrium since all forces are either horizontal or vertical. Summation of moments sa A. Okay. Why nag-start o moment? Because if you will sum up force sa X, you will have to announce AX and E. And if you will sum up force sa Y, you also have to announce EY and E. So wala kayo ma-solve. So you better start with moment. Sum up tag moment sa A. Pag sa E sad, you also have to announce EX and EY. Therefore, sa A ka sum up of moment. So that you will only have one unknown reaction, E lang. Okay, so substitution of moment sa A, this is the equation. E cosine 60, the perpendicular distance of this force to A is 8, 5, and 3, 8. For this one, E sine 60 is 5. Why 5? Because from A, 10 and 3, 13. No? 13 minus 8, so 5 lang. Okay, 13 man 13 minus 8, so 5. Positive, and then 20, clockwise, 20 times 10, 20 times 3 sa this one. And we can solve for RE. Okay. 60 degrees, 60 degrees na yung direction. Okay. And summation of force X, we cannot solve for AX. AX plus E cosine 60 minus 20. Right. And then summation of force Y, negative. Therefore, downward siya. Kaya nag-assume tag-upward. Tapos nag-negative siya, therefore downward siya. So we get the magnitude and direction along X and along Y. And then diagonal is the resultant, and then angle also. Okay. Basic, no? Use Pythagorean theorem to solve for the magnitude. And then arctan of Fy over Fx. That's the angle theta. Therefore, this is our RA. 8.2906 pounds. Direction is 58 degrees from the positive x-axis measured clockwise. This one. Another one. A rod AB hinged at A and attached at B to cable BD supports the load shown. Knowing that D is equal to 200 millimeters, determine the tension in cable BD and the reaction at A. So, let's draw the free body diagram. Ikat na to, ba? Okay, it was mentioned sa first part ani na video na you have to detach all connections nga naka-attach sa body. No? Like, i-detach na to ang support sa A, i-detach pa ang cable. And then we'll replace this one by the reactions. Okay, okay, i-detach na siya. Mo ang result. EX, EY. Assume rin na. But for BD, tension, dili siya assume kay tension ni. So it's always away siya. Okay. Dili. BD. Now, looking at the free body diagram, we have an inclined force. So we have to resolve this first into horizontal and vertical components before we apply the conditions. Now, based on a triangle, this is 100 and this is 100 also. Okay. Okay. Take note, D is 200 man. 200. So, coincide na siya. 200 and 200 man. So, 100 na Japan. 100. So, the angle is 45 degrees. Kaya equal man ang one leg sa right triangle. 100, 100. So, 45. So, this is TD, TBD, cosine 45. And then this one, TBD, sine 45. Pwede na, no? All forces are now either horizontal or vertical. We cannot apply the conditions. Again, we start with summation of moment because if we sum up force along X, we have two unknowns, AX and TBD. If we sum up force of Y, two unknowns also, AY and TBD. Therefore, we will start with summation of moment at A. We have four forces, 1, 2, 3, and 4. Okay, for this one, TBD sine 45, the perpendicular distance of this force to A is 300. For this one, the perpendicular distance is 100. No, 100. For 90, it's 100. For this 90, it's 200. And we have this one, TBD. Okay. Ang direksyon niya is 45 degrees, second quadrant. No? 45 degrees. Man. And summation of force sa X, positive, therefore, correct ng assumption na right. Sa Y, positive also, so upward. And then you get the magnitude and direction. You plot 135 and then 45. Diagonal is magnitude and then angle. Same with the other problem. Magnitude and direction. Therefore, this is our RA. 142.3 and then direction. Okay. Last problem. A lever EB is hinged at C and attached to a control cable at A. If the lever is subjected to a 500 Newton horizontal force at B, determine the tension in the cable, this one, and the reaction at C. Okay. So for our free body diagram, we will choose ECB as our rigid body. So, all others na naka-connect na, i-detach na to. Like reaction sa C, ang support sa C, i-detach na to. I-replace na to o reaction. As well as cable CD, AED. We'll cut it and then replace it with tension force. So, cut. So, our forces will be CX, CY, and then tension AED. Now, we have this one, inclined force. So, we are going to resolve this one into X and Y components. Now, to get the angle, we need to find this distance as well as this. Okay? Para maka-form ta og right triangle. So, compute na to. Pila man isa. How much is this? Okay. Let's find this angle first. Pero kay 30 ni equal na sila 30. No. Pwede na yun. Considering this right triangle, we have 250 hypotenuse and angle 30. This is sine. No? 250 sine 30. And it's equal to 125. While this one, this component horizontal is 250 cosine 30. And it's equal to 216.506. After this, we cannot get the direction of tension ED. Okay, considering this right triangle, we already have this one. 250 plus 125. That's 375 and then 216.506. So we cannot get the angle alpha. Sa A, alpha sa ni. No? Alpha is arctan of this one. 375 over 216.506. Our alpha is 60. Yeah. So pwede na. Okay, this one. 60 man eh. So TED cosine 60, TED sine 60. And then this distance 125 to 16.506. So if you will sum up 4 sa Y, sa X, we have to unknown CX and TED. If we sum up 4 sa Y, we have to unknowns also CY and TED. So what we're going to do is we sum up moment at C. We only have one unknown, TED lang. Okay, let's check. TED sine 60, the perpendicular distance is this 216. Okay. For TED cosine 60, the perpendicular distance is 125. But for 500, we don't have this distance. Pero makuha na because we have 230. So makuha na ito niya distance. Eh. So when we apply the conditions, sum up moment at C, need na ito niya distance. Eh. Kana. And that is equal to 200 sine 30 equal to 100. Okay. So sum up moments sa C. This one, TED sine 60 times 216. Okay, positive counterclockwise. This one is clockwise. P500 is also clockwise. So minus sila doon. TED is 400 newtons. And pwede na tayo mo-apply sa other conditions. CX, right, and then left. CX is positive. So, correct ang assumption na right siya. FY, CY and this one, positive also, so upward. Okay. And if you want to get the magnitude and direction, i-plot mo 300 and then 346. And then diagonal is the resultant and then angle also. Same lang. Use Pythagorean theorem para sa magnitude. Arctan dayon sa Fy over Fx direction. Therefore, this is our RC. 458.25 newtons, angle of 49 point, a direction of 49.106 from the positive x-axis in a counterclockwise direction. Okay, so again, as a summary of the steps you need to take, if there are inclined forces, you have to resolve it into x and y components before you apply the three conditions. And first, consider summation of moment if pag mag-sum up ta og force along x and y, we have two unknowns. So you go directly to summation of moment to avoid na i-repeat ang equation. Para diretso. So I hope that you have understand something or you learn something about, you understand the topic and learn something about the discussion. Thank you for watching.